Hi everyone, welcome back to our Linux Beginner to Pro series. Today is day 7 and we are on the topic disk management. In this topic, we'll be learning what are the implementations of disk management, what are the types of disk management, or how do we create the partitions and volumes into the disk management, and also we'll be understanding the requirements and how you will be getting the request to create the partitions and how will you do it. Before we start, disk management is basically a requirement where you have to create multiple partitions in order to store the different type of data, such as application data or website data or database data. So for these purposes, you have to create different partitions or volumes. Also, for keeping the root file system or the operating system files inside the system, you need root file system and boot and swap. There are a lot of volume types or partition types which you need in the system so that you can keep the data category wise. The benefits of disk management is if you create multiple partitions, your data is safe compared to kept into a single directory or a single partition, because if you are keeping it into different partitions and different volumes, even if your one volume gets corrupted, your data is safe into different volumes. And it is very easy to manage the permissions of the particular data, because if you are keeping it into the separate file systems, you can easily manage the permissions and authorization of different users who can access the data, who can read it, who can write it, or who can execute the files and everything. So it's very important to understand the disk management methods. Before we start, let us connect hard disk on our system. So in this Oracle VirtualBox, if you click on the settings of the particular virtual machine, go to storage, and here on the controller SATA, the second option says add hard disk. If you create here, I'm giving the size of 10 GB just to show you for example. Click on finish, and the one which is showing as not attached, here it is highlighted. Now click on choose. So VM app 1 VDI, this disk has been attached. Remember that your system must be in powered off state before you add it. However, into the real environments in your VMware or Azure or AWS cloud platforms, you don't need to power off your system in order to add a new hard disk. But here on the VirtualBox Manager, you need to keep your virtual machine in powered off state so that you can attach a new disk here. Now I'll be starting the virtual machine. So my system has started and I have taken the putty session with the root user. Always remember that you should be doing disk management either with the sudo privileges or with the root user itself. So the first command which we will execute in order to see what all the disks are attached to our system is lsblk. lsblk lists all the block devices. What are the block devices? In which device there are blocks and sectors, all those devices are known as block devices, such as hard disk drive or compact disk, which is in short known as CD-ROM. So all these devices are listed into the command output of lsblk. Now we have our HDB, which I just connected before the system powered on, that is of 10 GB. Now I'll be showing you how do we create the partition. Before that, what kind of request we'll be getting? Say that, for example, this is a app server where the application team wants a separate storage of slash app, and they need at least 5 GB of space to keep their application related data. This is just an example. They'll be not needing 5 GB or 10 GB. They may request for 50 GB, 100 GB, 1 TB or such kind of spaces, but we'll be taking the example with 5 GB. What is a file system in Linux? File system, as the name itself suggests, that a system where we keep the files. in some order or randomly we can keep it, but the system tracks where the file has been kept, the location of the file, and next time when you try to read it, it will be taking you to the same location and you will be able to read the file. So file system consists of two things here. One is partition or volume and another one is the directory. In Linux, you need to create a partition or volume first, then format it and then mount it on a directory in order to get inside the directory and keep your data, read it or write it. So you must understand this before you start understanding what is a file system and how do we create it. In short, we can say the partition and directories combination is basically the file system. Okay. Now there are two types of or there are two methods to create the partitions or volumes in Linux. One is standard partition, where we can create the partition out of one disk, and the partition size can be maximum to the actual size of the disk. And once the partition is created, it cannot be extended further, so your file system size also will be fixed. Once you have created your file system with a standard partition, the size will remain same till the end of its life. If you want more space, you may need to create a bigger file system and then move all the data from the previous file system to the new file system. That is the only way to extend the space or get the more space on the standard file systems. But if we talk about LVMs, LVMs are flexible, and those file systems can be extended later if required. We'll be talking about it into the next part. Today, let's understand about the standard partitioning. So fdisk is the command to create the standard partition. You have to give the path of the disk. Always remember all the disks are inside the slash dev. So you are seeing HDB here, but I am giving the path called slash dev slash HDB because your HDB resides inside the slash dev. Fdisk slash dev slash HDB, press enter. Here, if you are confused, you can press M to get the help. I'll be highlighting most important options which you need into daily life or day-to-day practice of creating the partitions. The first is D to delete a partition, N to add a new partition, and once you are done with creating the partition, you can either write the table to disk and exit or quit without saving changes. So if you want to save it, you have to press W, and if you don't want to save the changes, you have to press Q. Let's press N to create a new partition, and as we know, we need 5 GB of space. So we'll be creating a 5 GB partition here. There are two types of partitions into the standard partitioning. One is primary partition and another one is extended partition. On one disk, maximum 4 primary partitions can be created, and if you want more than 4, it will be created as extended partition. So if you do not give any option such as P or E, it will take default P. So if you press enter, it will take primary partition. Now partition number 1 to 4. So you can create maximum 4 partition. It is saying about the sequence of the partition. It's not that if you give 2 here, it will create 2 partitions. It will create partition number 2. That's the sequence of the particular partition. So you'll go from the 1. The first sector should be left empty. Let the system decide where the first sector will start. And the last sector, if you are well aware about these calculations, you can give the sector number, or it's easier to give the size plus 5G. If you press enter, it will create a 5 GB partition. And now we want to save it. We'll be pressing W and enter. Now if you do LSBLK once again, you can see the new partition of 5 GB created here. You have the partition, but this cannot be used just like that. You will have to format it first. There are multiple types of file systems in Linux, out of which two famous file systems are ext4 and xfs. ext4 was the default file system type till rhl7. rhl7 onwards, xfs is the default file system type. When I say default file system type, it is not that if you create a partition, you don't need to format it manually. Here, inside the operating system you will have to format it for whatever file system you want, but during the installation if you take root file system or boot file system, uh, the default file system type will be showing as XFS into the installation window, but here you will have to choose it. So there is a slight difference between ext4 and XFS file system type. uh, ext4 file systems cannot exceed more than 16 TB of partition size, whereas XFS can be created for 10 to the power 12 GB. And ext4, as I told you, it's a older file system type, where the XFS is newer file system type. And the third difference is that ext4 file systems can be extended as well as can be reduced, but XFS file systems cannot be reduced. Now you must be wondering that ext4 is the older file system type and still it is having extension as well as reduction feature while XFS lost one feature. What is the reason? If you are well aware about the partition and disk spaces, if you have created a, let's say, 15 GB partition and you have used 8 to 9 GB of space and you want to reduce the file system by 5 GB, however you will be left with 1 GB extra space, but still if you reduce it there might be chances of data loss and the file system corruption. That is the reason in XFS they removed the reduction feature. If you want to format a partition you have to run the command mkfs.ext4, or if you want to format it with XFS, write mkfs.xfs and then give the path of the partition, not the disk, /dev/hdb1. Now this disk has been formatted. The next step is to mount it. So you have to create a mount point. I'm creating mkdir/app. It's just a normal directory until there is a partition mounted on it. Once a partition mounted, it becomes the file system. So what is the difference between a directory and file system? When you have this directory /app, it is created under the slash. Now it will be consuming the space. If you are saving any file inside the /app, it will be consuming the space of root file system. But if you mount a partition on top of it, now the app directory will be consuming the space of that new partition. For this example, /dev/hdb1. Now the next step is to mount it /dev/hdb1 on /app. Now df is the command which will be listing out all the file systems available on your system. And if you want to see the sizes of those file systems, if you just run the df, it will give you a random number which you cannot understand what is the size of the particular file system. But if you run df-h, ignore the above file systems. This is because I have the containers and pods running on my system. But the last partition that you need to focus upon is /dev/hdb1, which is of 5 GB. It has been mounted on the /app directory. Now /app has become a file system. And if you want to list the type of the file system, use capital T option. It is saying that it is a XFS type of file system. Whatever file system you create, you have to make an entry in /etc/fstab file. If you do not create the entry into the /etc/fstab file, next time when your system reboots, this file system will not be mounted because your system doesn't know that there is a file system called /app. You have to tell the system by adding the entries in a fstab file so that next time when you reboot your system, the file system will be auto mounted. If you want, I can show you by restarting this system, and or you can practice yourself. Just don't make the entry in fstab and try restarting the server, and you will see that this /app will not appear into the df-h output. What you will have to do, vi slash etc slash fstab. You need this data, the partition path, the file system type, the mount point, and few other things that we'll be seeing into the fstab file. Go to the last by pressing Shift G and press O to create a new line here, and go to the insert mode. Now here slash dev slash hdb1, that is the partition path. Then where it is mounted, on the slash app. On the third parameter, we'll be mentioning the file system type, that is XFS. Here this default shows the permissions. If you want, you can reconfigure this by adding the different permissions for this file system, or if you are using defaults, that means it is using same permission as of the directory permission. Space 0, then space 0. This 0 will ensure that there are the logging being done, and the seconds 0 will be making sure. However, if it is 1, then only it will do the fsck. If it is 0, it will not do the fsck. Fsck is nothing but checking the file system continuity during the boot. If you keep it 1, the boot will become slow because it will start checking the file system before the boot, and it will take a lot of time. So we keep it 0 and then we save it. If you want to verify your fstab entry whether you have done everything correctly, just do mount-va. If it says already mounted or ignored, then you are good with your entry, or if you are seeing any error, you need to fix it. So this is all about creating a volume. Now, since the slash app file system has been created by root, if you do ll slash, you can see the slash app file system is owned by root and the group root. Group and others do not have any permission. Let's say there is a user called, I'm just checking what all the users are there on my system. Okay, let's say that SRE group, SRE user needs this file system. So you will do chown SRE colon SRE. SRE user and SRE group will be the owner of slash app file system. Now if you switch to SRE user, they can go to slash app, and if they want, they can create their own files. Now you can hand over this slash app file system to the actual users. They can go and create their own files. They can read it. They can do whatever they want. Okay. Now we'll be talking about how to clean up a file system which is unused. There is no data. If there is a data, you need to take the backup before you delete the partitions or delete the mount points. But if there is no data, how do you reclaim this space? First of all, you will have to go into the reverse order. First, delete the fstab entry. Do remember this, else you will end up with the maintenance mode of the operating system. So first of all, go to the last line. You can either comment it or you can delete the line. I'll not need this, so it's better to delete this line. Escape colon wq bang. Okay, I guess I'm logged in with standard user. Let me exit from here. Go to the last line, press double D, delete it, escape colon wq bang. Now you have to unmount the file system. Umount is the command to unmount the file system. Okay. Before mounting, we did formatting, but if we cannot do unformat, now we'll be proceeding to delete the volume. Fdisk again slash dev slash hdb. Remember that with fdisk you'll be using the disk path, not the partition path. Now press D. If you press D, since there is only one partition, it will automatically choose the partition 1. If there were more than one partition, then it will be giving you option to choose between the options, whatever disks are available or whatever partitions are available. You can choose which one you want to delete, but here it has already taken partition 1 because there was only one partition. Now press W to save it. Now if you press LSBLK, you can see SDB is back to 10 GB and there is no partition under it. So this is how we create the standard partition and delete the standard partitions. And you would have understood now how do we fulfill the requirements of the users and how do we set up the permissions. In the next part, we'll be learning LVM. So if you have liked this video, please like and comment if you have any questions or suggestions, and subscribe our channel for the next part. We'll be seeing you soon. Thank you so much.